Here it says write an equation for and graph a parabola with the given characteristics. So this first one here, we're given a focus of 3, -4. We're given a vertex of 1, -4. So if we just think about this, look at it on the graph. We'll just try to understand this by looking at the graph. The vertex is at 1, -4. The focus is at 3, -4. Well, what I know is that the focus is always in the, if your parabola looks like this, the focus is going to be here and the directrix is going to be here. If our vertex is here and the focus is here, that means our parabola must look like this. It must be the case where the y term is being squared. It must be the case where the p-value is positive, and so on and so forth. So this is going to look something like this. I'm not claiming it's going to be looking exactly like that, but it kind of gives us an idea. If the focus is 2 units to the right, the directrix must be 2 units to the left. So we start to get those pieces. So if we start putting this together, it's going to be y plus 4 being squared, and I'm going to have x minus 3 not squared, but then I have to think about my p-value. The p-value must be 2 because it's shifting 2 units to get the focus on the right, 2 units to get the directrix on the left. It's opening to the right, so I know p is positive. It's a positive 2. 2 times 4 gives me 8. Why do I multiply it by 4? Because it's always p times 4 in front of the term that's not being squared. So that is the first one right there. That's a rough graph, but we could always plug in, a 3 for x and see what our y values come out to be. We could plug in a 5 for x. You could do whatever you want to get some extra points to plug in here, but we have a general idea of what's going on. Let's look at the next one. The vertex is at -2, 4. -2, 4. The directrix is y equals 1. Okay, well, it must be opening up then, because I know my directrix is going to be perpendicular to the axis of symmetry, and since my directrix is 3 units down from the vertex, I know my focus is 3 units up from the vertex. I know that p also must be positive because I know that p-value is positive when a parabola opens up. So I'm going to start plugging things in here. I know it's going to be y minus the y coordinate not squared because the x must be squared for it to open up. Since my p-value is a +3, +3 times 4 gives me a 12, which I'm going to put in front of the term that's not being squared. Okay, once again, we could get some more points. If you really want to see what that might look like, let's put in 5 for x. All right, let's put in a 5 for x. 12 times y minus 4. Sorry, we're putting a 5 in for y. What am I thinking? Putting a 5 in for y. 5 minus 4 is 1 times 12 is 12. Take the square root of the other side. We have positive or negative root 12 equals x plus 2. We, of course, would have to subtract 2 from both sides. See what this comes out to be. We take the positive root 12, we take the negative root 12, we subtract 2 from it. Positive root 12 minus 2 is a 1.46. I take a negative root 12, and subtract 2, I get a negative 5.46, roundabout. So these are x values when the y value is 5, so that's a point of 1.46 up 5. About right there. We also have the point negative 5.46 up 5. So my parabola would be opening up a lot wider than what I originally just drew on there. But that's how we can get some more points, so this actually looks accurate. All right, questions about this? Okay, well, we're feeling good. Great.